Today we're going to review sections 2.1 and 2.2. So remember in section 2.1, part of what we were doing was looking at a diagram and then answering a bunch of questions from it. So we're going to use the diagram to the right to answer the following. We want to state the domain. So remember, domain is dealing with our x values. We read a graph going left to right, and the x values start at the left, go to the right as far as negative numbers to positive numbers. So if I'm looking at my graph, I see that there is an arrow on my graph on the left. There's an arrow on the graph on the right, which indicates that every single number for x is going to get hit. So that's negative infinity to positive infinity. If I'm looking at the range deals with the y values. So starting low at the negatives and going up towards the positives. So once again, if I look on the left, I see that the arrow is pointing down. So it is going to be hitting all of these negative numbers. So I start with negative infinity. And as I go up, it looks like the highest my graph is ever going to reach is right here at -2. It is included because all of those points are at -2, so I need to have a bracket there. As far as an x-intercept, we're looking to see where's the graph touching the x-axis. In this case, it doesn't look like it is, so we would say none. My y-intercepts are going to be on the graph where it's touching the y-axis. It looks like there is one spot where it's touching, and so that looks like the ordered pair then of 0, -2. In part E, it's asking for us to find the function at 2. So we're evaluating. Remember, the number that's inside is your x value. So I go over to the x-axis and I see where's my function at 2. Well, it's down here at that horizontal line, and it looks like that is going to then be -2 because that's our y value. And then the last question says, find the values of x for which f of x equals -3. So essentially they are giving us the y value. If I look at the y values here at -3, where is it highlighted? Well, it looks like the only spot where it's touching is right here. And so if your y value is -3, it looks like your x value is -2. Let's move on to some difference quotients. So I'm giving you a function f of x, and they're asking us to simplify the expression. So notice that the first half says f of x plus h. That means I want to substitute in x plus h into the function that's given wherever I see an x. So let's start there. So it looks like we've got one x, so that means that x plus h gets to get substituted in while everything else stays the same, and it's only happening one time. So there's the first half of my definition. Then I want to subtract, and now what I want to subtract is just f of x. So it's the function that they are giving us originally. Because there's more than one term, I'm going to put it in parentheses, so I make sure that the whole entire function is getting subtracted. That's then all over h. Okay, I got to get rid of the parentheses. So I'm going to go ahead and distribute the -2, and over here I'm going to distribute the negative. So we'll have a -2x minus 2h plus 19. Negative times a negative will give me a positive 2x. Negative times a positive give me a -19, and this whole thing's all over h. Now that my parentheses have disappeared, I want to start looking for like terms that I can combine. Looks like we've got a -2x and a positive 2x, so those are going to cancel. We've got a positive 19 and a -19. So those are going to cancel. So it looks like we have a -2h. This is all over h. And because you've got one term on the top and one term on the bottom, I see that they have something in common. They will divide. And so it looks like my final answer is -2. Let's take a look at another one. So we're using the same definition because this is the difference quotient. Now here's my function, f of x equals x squared minus 4x. So I'm going to start with the f of x plus h. So it looks like wherever I have an x in my original function, I want to substitute in x plus h. So it looks like it's going to happen twice. So we'll have x plus h, quantity squared, minus 4 times x plus h. So that takes care of the first half. Minus. Then if I look, I've got f of x. So it's essentially everything that I started with. Because there's more than one thing in my original f of x, I'm going to put it in parentheses. So x squared minus 4x. That whole thing is all over h. All right, I want to start getting rid of parentheses. So the first one is quantity squared. So I know that that means it's x plus h times x plus h. I can distribute that -4. So we'll have -4x minus 4h. And then I'm going to distribute this negative. So we'll have a negative x squared plus 4x. This is all over h. I still got to get rid of the parentheses to begin with, so I'm going to now distribute. X times x is x squared. We've got x times h, so that is an hx. And then we've got an h times x, so essentially there are two hx's or xh's. Did I say that twice? hx or xh. And then h times h is going to give us h squared. If I looked at what was not already in parentheses, it looks like I have a -4x and a +4x, so those are going to cancel. But then I still have that minus 4h minus x squared. That's all over h. And now that there are no parentheses, I can keep trying to combine like terms. It looks like x squared and -x squared are going to cancel. With the three terms that are left over, they're not like terms, but they do all have something in common. They all have an h. So I can factor that out, and that would leave me with a 2x plus h minus 4, and that's all over h. And by factoring out that h, now I've got an h and an h in both the numerator and denominator. Those simplify, and so it looks like my final answer, because there are no other like terms, would be a 2x plus h minus 4. Let's take a look at one more example. So here's my function. We've got f of x equals 6x squared plus 9x minus 1. So we want to substitute in that x plus h into every single x. So it looks like there's two different x's. So we'll have 6 and then in parentheses x plus h quantity squared plus 9 and then in parentheses x plus h minus 1. Now I want to move on to the second half. So I want to subtract, but I want to subtract that whole function f of x. Well, the whole function is this trinomial of 6x squared plus 9x plus 1. So I have that all in parentheses. So I make sure I can not multiply, but subtract everything. This is all over h. Okay, I want to start getting rid of my parentheses. So I'm going to keep the 6, but I know that x plus h quantity squared is x plus h times x plus h. I'm going to distribute that 9, so we'll have a plus 9x plus 9h. And then I'm going to distribute that negative. So we'll have a negative 6x squared minus 9x minus 1. That's all over h. Okay, I'm going to keep the 6, but now I'm going to actually multiply out the two binomials. So x times x is x squared, x times h, and then an h times x. So there are two xh's or two hx's, and then h times h is h squared. Notice that the terms that are not in parentheses, I have a 9x and a negative 9x, so those cancel. I've got a -1, nope, so that's not going to cancel. So that looks like that's the only thing. No, here, that was a mistake. This should be -1. So when I distribute, this should be a +1. So then those cancel. All right, so then I still have a 9h, and I still have a negative 6x squared. So now I can finally distribute the 6 to get rid of the parentheses. So we'll have a 6x squared plus 12xh plus 6h squared plus 9h minus 6x squared. In my numerator, looking for like terms, looks like the 6x squared and the negative 6x squared cancel. I see no more like terms, but I do see something that they all have in common. So I'm going to factor out an h, which will leave me with a 12x plus 6h plus 9 And then because there's an h outside of the parentheses and in the denominator, that simplifies. So it looks like my final answer is 12x plus 6h plus 9.